Welcome back to COSC 1436. This is chapter 2. I'm going to go through the slides for chapter 2. So make sure you go to Canvas, modules, and download those slides, and you can take notes as I go through it. Let me share my screen. Okay, so in this chapter, we're going to talk about all the different parts of the C++ program. In your first exercise, you typed a program and you ran it. And let's see if I can make this just a tiny bit bigger. It's not letting me. And so now we're going to go through and just talk about all the different parts of our program. So the first line here, we see what's called a comment, and it started with 2 forward slashes. When you type in 2 forward slashes, when the program is read, the compiler knows that this line right here just needs to be skipped. It's not, we don't look for syntax or look to see how it's formatted. It's just a comment, and we can skip this line. So truly the program begins at the pound sign. We talked about this in the last chapter, pound include IOStream. So we talked about how this is a library, and there's code in this library. So it's a file, it's a library file, and there's code in there, and all that code gets added or linked to your program. And what's in that code is it's things that tells the program how to use some either functions that you might have in your program that you don't define, or something like this statement here, this cout statement. So here we have using namespace std and standard. And if we add this using namespace, then we don't have to add standard : in front of cout. We can leave that out, and it makes typing the program a lot easier. And here we have the beginning of our function, the main function, which is required for all C++ programs. So when you compile your program, the first thing that it's going to look for, it's going to be the main function. If you don't have a main function, then your program, you're going to get a syntax error and you can't start the program. So this main function does have to have a lowercase m. All these letters have to be lowercase. int stands for integer. It has to be lowercase. It's a data type. What this means here on the left-hand side of the main function, is that at the end of this program, when this program runs, this program is going to return a 0 to the operating system. Now, if you're working in a real, I would say a real job, a real situation where you have large programs, you have programs that call other programs. So if this program is being called from another program, return 0, like when it gets to the bottom here, it means that, okay, cool, everything worked, nothing went wrong. But if it doesn't get to the end of the program, if something happens, some kind of error happens in the middle of the program, then it will return either a number, a code to let whoever's looking at the program know what went wrong. Like a 1 could mean something, a 2 could mean something else. So return 0 just means it got to the end of the program, everything executed, whether it calculated things correctly or not, it doesn't matter, but it got to the end without exiting with some kind of weird error. So the best way to explain it is like, when you're running a program and all of a sudden the program freezes or the program unexpectedly exits, that would be not getting to the end of the program and not returning a 0. So that's what that means there. And when you create a main program, you don't have to have int here. You'll see another word, a keyword called void, and then you won't see a return. So void means that you will not have a return. When you have a function, you have to have a beginning curly brace, and at the end of the function, you need to have an end curly brace. And so these curly braces are what makes a block. And we'll use blocks not just for functions, but we'll use these blocks for other things in our programs, like control structures, which would be like an if-else statement or a repetition statement to repeat something over and over again. So we have int main, open curly brace. This is our output statement. This is what's going to output to the screen. It's going to output hello there. And then we're going to end the program, and it just returns 0 to the operating system, and it means everything went okay. Inside these double quotes is our string. So double quotes are used, or not double quotes, but 2 quotes are used with a string. So anything you put in quotes will output exactly as you type it. So if you type a space in there, it'll show a space. If you misspell something, it'll be misspelled. It's just literally what you type will show on the screen. And then here we're ending with a semicolon, which we end all statements inside our curly braces with semicolon. There's not a semicolon at the end of main. Don't put that there. If you put a semicolon there at the end of main, then none of this in the center will happen. These are some special characters. So we have the forward slashes, and those are your comments. The pound sign is the beginning of the preprocessor directive. So that's going to be used for all our include. So we include all the library files. The less than and the greater the less than and greater than signs are used right here to wrap around the name of the library that we're including. And we have parentheses that are used here after main. And when we talk about functions later on in further chapters, we'll talk about why we need those parentheses. Right now, you just have to have them. We have the open and curly braces that we talked about, which is our block. We have the quotation marks, which we talked about. Quotation marks are going to be for our strings, and then the semicolon to end each statement. The cout object. So cout is an object, and an object is like a variable, except it the object it's like you're creating an instance of a class. And we haven't talked about classes, but whenever, for example, you create a variable like the variable x, and it's an integer, and you're creating one integer. Here we're creating a cout statement. And to be able to use this cout statement, we got to have 2 things. You got to have the IO stream included, and you got to have your using namespace standard, because although the using namespace standard is not required, if you don't use it, then you'll have to put std : in front of cout. So this less than sign is called an insertion operator. It's also defined inside IO stream. So less than is not something that C++ just magically understands. and cout is not something it magically understands. It's got to have that IOStream library. The cout object can be used to send more than one item to cout or to console out. Cout is your console output, so it's going to output to the screen. So C stands for console and then out for output. Here we're outputting hello space and then there. This is not necessary, of course. I can just take out the less than sign and take out these quotes here and just put it together. But this is another way that you can show it. Here's another way that you can do it. You can put hello on one cout statement, there in another cout statement, and it will print side by side. So this will print side by side, hello there, this will print side by side. These will not print on separate lines. That's going to require something else to print on separate lines. This produces one line of output. So this again prints out on one line. Programming is fun. Does not print on two separate lines. Then we have something, if you do want a new line, so if you want to have programming is on one line and the next line, you want the word fun, then you have to use this manipulator called endline. END lowercase l, endline. So endline will just, it's like pressing the enter key. It'll go to the next line and then fun will output to the screen. I want to go ahead and share. Let's see. Go to Google Chrome here. And I'm going to open a new tab. Oh, that's not what I meant. Okay. So right here, notice that you have std : : so if we don't want that, I'm just going to make this just a little bit bigger so you can see it. Right now, I'm going to just delete all this. Colon. Here's int main. So I'm going to output hello world colon. My run button. Okay, just outputs down here at the bottom, hello world. And then again, if I do hello space world, it's gonna look exactly the same. And if I put a semicolon here and do cout and leave everything else the same, it's going to do the same thing, hello world. But if I add an end line here, ENDL, not a one, then it's going to print hello on one line and world under the other line. Okay. Let's see. Yeah, I'm just going to share everything so I can just easily go back and forth. Hopefully this will work. Okay, so we have that. The next thing here is just telling you that ENDL is a lowercase l, not a 1. Another thing you can use is \n. \n works just like ENDL. It gives you a new line. The only thing is that you can put it inside your double quotes. So here it would print out programming is, and on the next line it prints out fun. Okay, so the pound include directive, we said it inserts the contents of another file. So there's another file that's a library. It's a preprocessor directive. It is not part of the C++ language. Pound include lines are not seen by the compiler. And then it tells you to remind you not to put a semicolon at the end of the pound include line. Okay, let's look at variables. So our variables are definitely very important in our programs. It's going to store information that we can manipulate, output, and we can store it to files. We can output to anything that we want. So here we have the variable name item, and it's defined as an integer. And you've got to define, you have to tell what, you have to define a variable before you use it. So before you use a variable, you have to say, okay, I want a variable that's an integer, or I want it to be a string, it's going to hold a character, and then you're able to use that variable. So here's a variable definition, int number, semicolon. Int, again, has to be lowercase. A literal is a value that is written into a program's code. So literal is hello there, or that's a string literal, or an integer literal would be the number 12. So here we have a variable called apples. It's defined as an integer. So apples can hold numbers, 10, 20, 40, 50, like that, 1,000. And here we're assigning 20 to the variable apples. And 20 is an integer literal. We just assign that integer to apples. Here we have two string literals. And again, this is going to output to the screen exactly what you type in, exactly how you spell it. An identifier is a programmer-defined name for some part of a program. Like an identifier can be a variable, identifies your variable. It can be a function, so the name of the function, a constant, the name of a constant, so something that doesn't change in your program. Those are going to be your identifiers. There are rules for naming identifiers. One of the rules is that an identifier cannot be a keyword. All these are examples of keywords. So C++ knows exactly what these words means. They are reserved. And these cannot be used as identifiers. So if you look on here, integer, it's right there. There's int. That's a keyword. Okay. So when you create a variable name, you want to make sure that you use a name that's meaningful, so that, I mean, it's fine to use the variable X and the variable A and the variable B, but it's hard as when somebody, if I write the program and then I leave the company and somebody has to come in and read my program and make changes to my program, or maybe fix an error in my program, It's really hard for them to read my program if I just have simple variables like X and Y and Z. So they have to be meaningful. The purpose of the variable is to hold the number of items. This particular example, hold the number of items ordered. So the variable could have been X, but here I know, okay, this is holding the items ordered. It's simple. It's easy for me to understand. So the rules for defining a variable. The rules are that the very first character in your variable needs to, it can only be a letter or an underscore. So alphabetic character A through Z or an underscore. It can be capital or lowercase. After that, you can use numbers, more characters, or underscore characters. And again, it can be upper or lowercase letters. So it has to start with either an underscore or a letter. And the name of the identifier can only be letters, numbers, and underscores. That's all you can have it. You cannot have any spaces. You can't have a pound sign, nothing like that. So here are some examples of some valid and invalid identifiers. Total sales, that's valid, valid. This is not valid because it has a period. This starts with a number, it's not valid. And this ends with a $sign, so it's not valid. The reason you cannot start with the number is because when the compiler sees a number, it thinks that you're about to do some kind of calculations like 4 times something. So it gets confused and it doesn't know what to do. That's why we don't start with the number. You'll notice that there is a format that you'll notice in all identifiers, not all identifiers, but all variables that we create. And that's that we typically start our variables with a lowercase letter, and then the second word will start with a capital letter. So that's just a formatting. It's not required. It's just a formatting preference that we follow. And depending on where you work, the company you work, they may have a different way of saying how variables are defined. So you may be given a specific way of how they want variables to be defined. Integer data types. Integer variables can hold numbers such as 12, 7, and -99. We have something called a short integer. This is a data type. It can only hold 2 bytes. This is the range of numbers that these data types can hold. So this is the range. We just use an integer. We're going to be using integers. It can hold pretty big integer numbers. So here we are at the thousands, millions, trillions, right? I mean billions, sorry, billions. So it can go up to 12,147,483,647. So that's a pretty big integer. And typically for integers, we'll use it for when we're getting years, or we're getting an amount, how many did you buy, or what's the grade. But these are the different data types for integers. If you're doing a lot of math calculations and you have to be precise, then these are some of the things that you want to look at. You know, what numbers am I getting? How big will the numbers get? And then do I have in a data type that will hold that big number? So when you're defining variables, if the variables have the same data type, you can define them on separate lines like this, int length, int width, or you can define them on the same line, int length, comma, width. Variables of different types must be in different definitions. So here we have integer, checking, unsigned integer, miles, long, diameter. So long is a different data type. So we're going to put it on a separate line. If you had a string, it would be in a separate line, always ending with a semicolon. So here we define the variable checking, and then we assigned -20 to checking. Notice on the assignment statement, your variables on the left, your values on the right, and it has to be that way. It cannot be written any other way. Variable on the left, value being assigned on the right. An integer literal is an integer value that is typed into a program's code. So we talked about that earlier. 15 is an integer literal. All these are integer literals. Integer literals are stored in memory as ints, as integers. To store an integer constant in a long memory location, you put an L at the end of the number. To store an integer constant in a long memory, we put 2 L's. You don't have to worry about this. I'm not going to be using these. Constants that begin with a 0 are base 8, and constants that begin with 0x are base 16. And this is how you, these are things that we're not going to be using either in this class, but it's just an FYI. So character data types. So we talked about integer data types. Character data types can only hold one character. So if you look at your keyboard right now, you have lots of characters. There are letters, there's numbers, and there's special characters like a pound sign, a dollar sign, a question mark. All those are characters. So here's an example how we define a character, a variable that can hold a character. So char letter equals C, the capital C. And in memory, we're going to, that capital letter C is actually stored at 67, which is ASCII code. And so the capital A starts at ASCII 65, B 66, capital C 67. Nothing that you have to know or memorize, but it is called an ASCII character. There is something that's interesting. If you look at ASCII, whenever you're comparing characters, like let's say you were going to compare the character, the capital A and the lowercase a, and you want to know which one's bigger and which one is smaller, you have to look at the ASCII chart. And I don't think I have that here. If it comes up, I'll show it to you. But every character on the computer will have an ASCII. And so if you compare letters, let's just compare capital letters, and you say, is the letter A less than or greater than the letter C? Well, in ASCII, A is 65. So A is less than the capital C, only because 65 is a smaller number than 67. So when comparing strings and when you're organizing things, alphabetizing, then that is what it's going to use. It's going to use the ASCII values. And when we need that, I'll go over it again. When you have a character, you put those characters in single quotes and assign it to the value. So here, notice that we have single quotes around the letter C and it's assigned to letter. If you don't put those single quotes, the program thinks that the capital C is it's a variable. It's going to think C is a variable. And so it's going to give you an error because C is not defined. You didn't define C. You meant C to be a character. Okay, so it's just an example. We have character letter, we assign A, single quotes again, around the A. and then we output letter. Notice that when you're outputting letter here, we don't have the double quotes, because if you put the double quotes, it doesn't output the letter A, it outputs the word letter, because that's the string little. So you got to get those double quotes out of there, because you're now wanting to show or to display the variable letter, the character. This here is going to give you a new line. And then we're going to output the letter B, and then new line, and then end program. So we say A, new line, capital B. All right, character strings is a series of characters. So we have the character string hello, and because it's more than one character, we're going to put double quotes. And this is how it is stored. We have H, it has its own little location, ELLO. The null terminator at the end means that this is where the string ends. So at the end of each string, you'll have a null terminator. And that comes in handy when you are when you're like reading files. It's gonna be the end of the file or the end of the string, like read until the end of the string. Now let's say that you type hello space world. The space is a character, so the null terminator will not be until the end of world. So hello world is one string, even though you have a space in there. Space is a character. The string class. Okay, so what this is saying is that if you want to use the string, if you want to define something as a string, so let's say that your program, you want to get somebody's the first name, somebody's first name, you're going to need to create a string variable. And to create a string variable, you actually have to use a library called string. It's not like int. Int is a keyword. String is not a keyword. String is actually a special data type that is defined in this library. And so here we're creating two strings. We're assigning George to first name, Washington to the last name. And here we're going to output George space Washington. Here we have string movie title. Notice here we have included the string library. Again, without the string library being included, you won't be able to use the string data type. Here we're assigning this string, which is in double quotes, to movie title. Floating point data type is a data type that whenever you want a value to be able to have decimals, like maybe you're averaging grades, then you know you're going to need decimals. Your output's going to might have a decimal like 96.5. Then you need a floating point data type. You can use float, double, or long double. So these just the difference between a float and a double is double the size of a float, and so long is just even longer. It stored in a form similar to scientific notation, or all floating point numbers are signed. So float is 4 bytes, a double is 8 bytes. Long double precisions is between, it's the same. So it says some compilers use 10 bytes for long doubles. This one, this allows a longer or a bigger range. So here's a fixed point decimal notation, 31.4159. And in And here we have 0.0000625. Oh, and then this is how we write it in, yeah, in scientific notation. So this written in scientific notation and this written in scientific notation. These are doubles by default, but we can force them to be floats or long doubles. So here's an example of a float distance. So distance equals 1 point, and we have a scientific notation of our number, mass, and then here we output those values. Boolean is a false or true. So all that we can store in Boolean is a 1 or a 0. When you assign true to all done here, you're assigning it a 1. False, you're assigning it a 0. So we don't put a 1 or 0, we just use the words true and false, which the compiler knows to mean 1 and 0. So Boolean is whenever you maybe are using maybe a conditional statement. If this happens, then it's true. If it doesn't, it's false. And in other cases. So here's just showing you that it outputs a 1 or a 0 when you assign it true or false. The size of operator gives the size of any data type or variable. Okay, so double amount. A double is stored in, and then you say size of double, bytes. Variable amount is stored in size of amount. So amount is a double, and this here, size of, gives you the size of the double, like how many bytes are in double, so you can see. And this will tell you the size of your variable amount. And they will be exactly the same because amount is of size double. So if double is 8 bytes, then amount is going to be 8 bytes. So that would be, this would be a fun thing to play with and enter. And just look at the size of the different data types. You could do int amount and do the same thing here, char amount, and then see what the size is. Okay, so variable amounts and initialization. Variable assignment, sorry. So whenever you create a variable, you want to initialize it to something. When a variable is created, so like if you say int amount, semicolon, what happens is that amount is space is created in memory for that variable amount, and whatever's in that space, it can be junk. So it could be something that was stored there before, and that memory was clear. But when you stop using memory, things don't just get erased. So it actually, as you're working with the memory, with the program, there could be, the memory's just released, and there could still be some data there. So if I define a variable, I'll just show you, it's just better if I show you what I mean than tell you what I mean. So let's go here. Okay, so I'm going to create an integer call amount. And I'm not going to give it a value. And then I'm going to see out. I'm going to output to my screen. I'm going to display the variable amount. Okay. Semicolon. Run. Okay, so this one gave me a 0. So initialized it to 0. Something. So let's say that I initialized it to 100. Of course, this time it's going to run and it's going to give me 100. Okay, so if I go back and I don't assign it anything and I run it again, let's take a look here. See how there's an X there? So if I put my cursor over the X, it says initialize the variable amount to silence this warning. So this is a warning, and it's just warning me like, hey, you didn't give amount a value. Then here's another warning. It says, again, we did not initialize amount. And that's what it says in here. So it's just a warning. When you get a warning, your program still works and it compiles and it will work. The only time that it stops working is if you get an error. So for example, if I leave out my semicolon and I run it, then I get an error. And the error is expected semicolon at the end of declaration. So it's telling me exactly what I missed. I missed my semicolon. So in this case, when I run it, I'm still getting just a 0. But with some compilers, when I run it, I won't get a 0. I'll get some weird number. And that weird number just comes from memory. It's grabbed whatever memory location. That memory location didn't get cleared out. It has something old in there. And so it shows me that number. Earlier, we were looking at size of. So if I put size of amount, and then let's just go ahead and assign, let's get the warning off, assign it 0. So the size of the integer is 4 bytes. Now, if I do size of int, it gives me 4 again. So that's my size of. So the integer is 4 bytes and amount is also 4 bytes. While I'm here, we'll just go over if I have a character, remember that, let's say that the character is grade, letter grade. And then, so for letter grade, if I want to initialize it to something and I don't want to initialize it to an actual letter, and I don't want that warning, I can just put an open and a close apostrophe. And then I can say letter grade equals whatever, A, back, capital A. Remember, not double quotes, but what some people call single quotes, or it's just really an apostrophe. Oh, I did not display anything. It helps if I see out letter grade. Oh, forgot my space. There we go. So I initialized letter grade to a space. I assigned it the capital A, and then I displayed the capital A. See out capital A. I can do this with strings. Here's string being defined right here. Second pound includes, so I can define a variable named string. Now, when I define my variable named string, I'm going to use double quotes. Jeanette, that is my first name. And then I can see out the variable name. I see how it's Jeanette. Okay. Going back to the presentation. This is like I said earlier, when you do an assignment statement, you variable comes first, then the equal sign, then the value you're assigning. Can't do it the other way. So here we're just initializing some variables. And okay, so this is declaring variables with the auto keyword. Sorry. C++11 introduces an alternative way to define variables using the auto keyword and an initialization value. So here's an example. Auto amount equals 100. So automatically C++ is going to pick the integer data type. Here's going to pick double, character, long. So automatically it just picks the correct data type. For our programs, for now, I want you to pick the data type. So I don't want you to use auto. I want you to actually pick a data type. So you learn the data types. Scope. The scope of a variable, the part of the program in which the variable can be accessed. So the scope of a variable is once you define the variable, you can use the variable. And what we're doing is we have one function called main. And so if I define the variable at the top, then I can use it all the way after main. Later on, we're going to get into creating other functions, and there's going to be other scopes. But for right now, here I see out value and I define it on the second line. I can't do that. I got to define it first, and then I can use value. That's all that is saying there. Arithmetic operators. So these are operators that we use for performing calculations. C++ has unary, binary, and ternary operators. So unary, one operand. So we can we have binary, two operands, and ternary, three operands. So let me give you an example of what this means. So here we have, let's look at the binary arithmetic operators. We can use plus, minus, the asterisk for multiplication, the / for division, and the % for modulus. Modulus just gives you the remainder after you divide. So if you divide 7 divided by 3, it's going to be 2, because 2 times 3 is 6, with 1 remainder. So this is the remainder. That's the remainder. Make this bigger. Here is an example of how we can use the arithmetic operators. So we have a variable called base pay rate, and base pay rate is $18.25. So this is the base pay that these people get paid at this job. And then regular hours is 40 hours. So it's what they work per week, 40-hour work week. And then here we're multiplying the rate times the 40 hours, and that's regular wages. So this is multiplication. This will get calculated first, and then it gets assigned to regular wages. Regular wages then over here gets added to overtime wages. So got to calculate it here to then use it over here. Okay, this is really important. When you use the division sign, the / sign, with two integers, you're going to get an integer. You're going to get an integer displayed. Even if it has a decimal, you're going to get an integer. So 13 divided by 5, the value of that is 2.6, but you're not going to see 2.6, you're just going to see 2. If you want to see the 0.6, the floating point value, you have to make one of them, either the 13 or the 5, you need to make it a decimal, a floating point value. So add a 0.0. So 13 divided by 5.0 equals 2.6, or 91.0 divided by 7 equals 13.0. So this is super important when you are calculating, especially let's say we're calculating students' averages. We want to see that point something, right? Because if it's 0.5 or above, it's going to go up a point. Modulus, again, gives us the remainder, and the remainder is going to be a whole number. It's always a whole number. And so we cannot use floating point numbers with modulus. So this is not allowed. We talked a little about comments later. Comments are ignored by the compiler. They start with 2 forward slashes. We use them to document the program. What's important about that is, one, who created the program? That's important when you work for a company. Who wrote this program? When was it written? So I know that Jeanette wrote it. Maybe Jeanette still works for the company. I have questions. I can get Jeanette, I can get her to come and explain to me what's going on in the program. The other thing too is, as I'm writing the program, we write it with enough comments that if I'm not available or if I'm not working for the company anymore, somebody can go and look at that program and be able to follow it. So the comments helps to explain what I'm doing in the program. So here's a single line comment, //. So you can put them at the end of lines. You can put them at the top of a line. It doesn't matter. If you have the //, it is ignored by the compiler. You can also have multiple lines of comments, like a big block of comments. And that's going to be a / with an asterisk that begins the comment. Then you can type all you want and then end it with a asterisk / again. So / and /. Named constants. So constants are things in a program that are not going to change. For example, if I'm writing a program and I'm using the sales tax, for example, sales tax does change, but it doesn't change daily, doesn't change monthly, doesn't change yearly. It's a long time before we hike up a sales tax. And so I could make sales tax constant, and I should, especially if I'm working for a big company that uses a sales tax, like maybe I'm Tum Thum, Sam's, Costco, whatever, and they're going to use sales tax. Well, it's really important that I charge the correct sales tax when I make those calculations. So tax is going to be a constant. Everybody in the company is going to use the name. First include a library that contains the value and use that name so that we're all using the correct tax amount. And so when we're defining a constant, when we look at the program, we want to know what's a constant, what's a variable. And the way that we can tell that is by making our constants all capital letters, the identifier, make it a capital letters instead of lowercase letters like your variables. This is not required. It's not going to be wrong. It's not going to stop compiling if you don't make it capital. But this is so that somebody else can come back through, read your program and say, oh, that's a constant. That doesn't change. Oh, that's a variable. It's easy to identify what's what. Also, you're going to be able to identify it because it has the keyword const. So const, data type, name of the constant, value of the constant. The value is required because it's a constant, and constants cannot be changed. So later on in the program, you can't say, oh, tax rate equals 0.08. You can't go do that because it's a constant. And once you define it with one value, you may not change it any time in that program. Descriptive names. I think I went over all that. So here's an example of using a constant. So const double pi. pi is used to find the circumference of a circle. And so pi is 3.4159, blah, 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 it goes on forever. So we define the value of pi. We define here they're making diameter a constant. They're multiplying pi times diameter. But diameter could be something that's not a constant. It could be something that a user enters. So they enter the diameter, and then you take pi times whatever diameter they enter. So it would be a variable, and it will return the circumference of your circle. Okay. Again, same thing, like let's say it's the area of the circle. So you would ask for the radius, you would ask, that's it. So you would need the radius to find the area, and then radius would be an integer, pi would be a constant, and then your formula would be area equals pi radius times radius, because it's r squared. Programming style. The programming style is the visual organization of the source code. Include spaces, tabs, and blanks. It does not affect the syntax of the program, but it affects how we read the source code. So, for example, you see these blank lines right here. Line 4 is blank, line 10 is blank, line 13 is blank. That's not required. That's there so we can read the program easily. These comments are there to help us read the program. So we have a space before we begin our function main. We have a space after we define our constants. We have a space after defining our variables, so on and so forth. So we don't want to just cram everything without having spaces. Make sure you have spaces so that the program is easily readable. By the way, when you work for a company and you write code, typically in big companies, there will be code reviews. And the code reviews, you have a team of people, and this is actually kind of intimidating because everybody's looking at your code and they're looking to see how you wrote the program. So what do your comments look like? What do your variables look like? Those identifiers that you created, your constants. Is your program easily readable? And so it's a programming style, like a writing style, like when you're writing a paper, and then they'll give you some feedback and help you with writing a better program. And the reason we want to do that, again, because the life of the program is going to be there for a long time, and a lot of people are going to have to go in and edit your program. They can add to it. Maybe there'll be errors that come up later on, and they'll have to go in and try to find those errors. So programming style is very important. Okay, that's the end of chapter 2. For